Today's lesson is going to focus mainly on the law of sines, but we're going to start off with being able to find the area of a triangle when it's not a right angle. Now, this formula works when you're dealing with one angle between two sides. Now here you notice we have an angle directly between two sides. Then we can find our area of a triangle. Now, just notice that when you're looking for your area, it's 1/2 your first side times your second side times the sine of the angle in between. Now, this formula that we're dealing with only works if you have the angle in between two sides of a triangle that you know. Now you can type it into your handy dandy calculator just as you see it, and you end up getting 26.487. So to the nearest tenth, we'd write 26.5. Notice your units are kilometers, and so you're dealing with area. It'll be kilometers squared for your answer. So if you're ever dealing with the area and you have an angle between two sides, you can use this idea of 1/2 your first side times your second side times the sine of your angle. Now, let's go ahead and take a look at this law of sines. Now, law of sines is really this thing right here. Sine of an angle over its opposite side equals sine of another angle over its opposite side. It's still equal to the sine of the third angle over its opposite side. Now, typically, you're going to only be dealing with 2 of the 3 fractions at a time. So most of the time, you'll be dealing with something like this, or you'll be dealing with something like this. Now, for me, and it's only me, I like to have whatever it is I'm looking for on the top. So if I was looking for an angle, I go sine of that angle, put that on top like I have in yellow, over its opposite side, equals sine of the angle over its opposite side. If I was looking for a side, I would use what's highlighted in blue and put my unknown side on top, over my opposite side equals the sine of my angle over its opposite side. Now, just know that for law of sines, you have to have an angle and its opposite side that you know. You have to have at least one of those opposite pairs that you know the angle and its opposite side. If you don't have that, well, then you can't use law of sines. But you have to have this opposite pair, an angle and its opposite side that you know. Now, you should remember from geometry, these options prove triangles congruent, so there's only one possibility. However, when you were dealing with the side-side angle, it does not prove triangles congruent. In that situation, it may not form a triangle, it may form one triangle, or it may find two. So if you have a side-side angle situation, you have to use a flow chart that's on the next page here. Now, we will go ahead and take a look at this. I'm going to just draw this out a little bit. It's not given to us, so I'm going to draw myself a picture because for me, a nice visual is helpful. I'm going to put my angle right here in the lower left corner. I'm going to put C there. So therefore, side C would be opposite of that. Now, this is going to be my side next to my angle. I'm going to choose to put it here. You'll notice we have a side, side, followed by an angle. So we have a side, side angle situation. Whenever you have that, you have to take a look at your flow chart. There's a bigger version of the flow chart in the next page, but for the most part, it comes down here. Now, for the sake of this flow chart, please note that A, lowercase a, side A, and angle A are always the paired side. What we have over here in red, the paired side where we have an angle and a side that we happen to know. Now, if it's not a side-side angle, we can just go ahead and solve it like normal. We don't have to worry about this flow chart. But if it's a side-side angle, we have to look at this flow chart to figure out how many angles we're dealing with. Now, we have a 16-degree angle. We know it's not obtuse, so we don't have to be concerned about this. 16 degrees is less than 90. So we know we're going to be dealing with this over here. So for our problem, 7 is our opposite one, and the 26 is our adjacent one. Now, you'll notice your 7 is less than your 26, so we're going down this over here. Well, then we have to go ahead and figure out the 7, and then 26 sine of our angle that we're given, and see how that compares. So if we go ahead and work this out, we work this out in green, 26 sine of 16 degrees, we get, if it'll write, 7.1666. And once again, over here was a 7. Now we know the red 7 is less than that. So that's what we have right here, which means we have no solution, no triangle form. So we can't actually solve it because there's no triangle. Or number of triangles, you could say, would be 0 triangles. Now just know that when you're dealing with, oh, I ended up putting one too many S's up here. When you're dealing with a side-side angle, if it's no triangle, you don't have to solve it because there's not a triangle, you can't solve it. If there's one triangle, you'd have to solve it. If there's two triangles, all you have to do is just identify that it's a two triangle situation, and you don't have to do anything beyond that. You don't actually have to solve the two triangle situation. Well, here's a bigger version of the flowchart, which is all on your reference sheet, so you'll have access to it. Now, when we look here, you'll notice that we have an angle followed by another angle followed by a side, which is an angle, angle, side. It's not that side angle stuff, so we don't have to be concerned about the flowchart. We can just go ahead and use law of sines and power on through it. Well, the easiest thing to find here is our third angle, because you know your angles all add up to 180. So I'm going to find angle B. So I can go 180 degrees minus my first angle minus my second angle minus, not equals, and type that in, and I would get 59 degrees. Now notice we have an opposite pair, so we can use law of sines. So now I have to decide what I want to find first. Doesn't really make a difference. I could go ahead and find side B, or I could find what's opposite of angle A, which would be side A. I got to find both of them. It doesn't make a difference which one. I'm going to choose to go ahead and find A. Now, I like to find or have what I'm looking for on top. So I'm going to put my unknown side on top. So I'm going to go the sine of my angle opposite of A, which is 45 degrees, is equal to, and I will use an opposite pair. I just put my side on top, so I got to, for my opposite pair, put my side on top over the sine of my angle opposite of that. So now to get A by itself, right now A is divided by the sine of 45. I got to multiply both sides by the sine of 45 degrees. And so I would have 26 sine of 45 degrees divided by the sine of 76 degrees. And then I can type that into my handy-dandy calculator. So I'm going to go 26 sine 45, close my parenthesis, divide sine 76, close my parenthesis, and type it in, and I would get to the nearest tenth 18.9. Now, I cannot use the Pythagorean theorem to find my third side because it's not a right triangle. It's not, I can't use SOHCAHTOA because it's not a right triangle. So I'm having to go back and go through using the law of sines again. So I'm going to be looking for side B, so I'm going to choose to put that on top over the sine of its opposite side, equals my opposite pair, which was the 26 over the sine of 76. Now to get B by itself, I need to go ahead and get rid of dividing by the sine of 59. So I'm going to multiply both sides by the sine of 59. And so then I end up getting 26 sine 59 over the sine of 76 degrees. And I can type this into my calculator. Go 26 sine 59 degrees, close my parenthesis, divide sine 76, type it in, and I get 23.0. Now, since it says to the nearest tenth, I would really need to have that 0.0 to indicate I went to the nearest tenth. So I'm going to start out by basically drawing this out. Let's see, A's got to be one of the other angles. I'm going to just choose to put it here for no apparent reason. It's got to be just one of the other two. And then that means angle B would be up here. So therefore, side B would have to be opposite of that. So this down here would be side B. You'll notice I have a side in between my two angles. It is not in side-side angle situation, so I don't have to be concerned about number of triangles. I can just go ahead and use law of sines and work this out. Now, if I know two sides, the easiest, or two angles, the easiest thing to do would be to find the third angle. And now, remember, your angles add up to 180, so go 180 minus the 14 minus the 61, and I get 105 degrees for my angle B. Now, that's 105. I now have my opposite pair. I did not have an opposite pair before, but now I have my opposite pair of the two blues, so I can go ahead and work this out. Now, when I'm working this out, I need to find side A, which is opposite angle A, and side C, which is opposite angle C. It doesn't make a difference which one you do. I'm going to go ahead and choose to find my side A. So I'm going to go A over the sine of that opposite one. And like I said before, I like to have my unknown on top because it just saves me a step in solving. You don't have to though. And then I'm going to go ahead and use my opposite pair. The side opposite the angle I know, so I'll go 32 over the sine of the angle I know. And then to get A by itself, I got to get rid of dividing by that sine of 61. So to undo that, I'm going to multiply both sides by the sine of 61 degrees. And so I'd have 32 times the sine of 61 over the sine of 105. And I'm going to type that into my calculator. I'll go 32 sine 61, close my parenthesis, divide sine 105, and I get 29.0 degrees. I need to have the point zeros because it says the nearest tenth. Now I'm going to do pretty much the same idea for the red. So I'm going to take the sine, or C, over the sine of the angle opposite of that. And then I'm going to use my opposite pair again, which is the 32 over the sine of the 105. Then to get C by itself, I need to go ahead and multiply both sides by that sine of 14. When I do that, it gets rid of that dividing by the sine of 14 and ends up putting it over here on the side with the blue. And then I can type that in, and I can go and type in 32 sine of 14 degrees, close my parenthesis, divide by sine of 105, and I get 8.0. When I look at the next problem, I'm going to draw this out. I'm going to put my angle here. You can put it in any one you like. We also have side A, which would be this one over here, because it's on the opposite. And then this is one of my sides next to my angle. I'm going to choose to put it here. You'll notice that we have a side, followed by an angle. So that is a side-side angle situation. When it's a side-side angle situation, we need to go ahead and refer to our flow chart to figure out how many triangles that we have. You'll notice for our opposite pair, which is the A's, and we're dealing with an acute angle, so I'm dealing only with this over here. My A is the 25. My B is the 32. We know that 25 is smaller than 32, so we're going down this side here. So then when we come down here, we need to figure out how our opposite side of 25 is related to our adjacent side times the sine of our angle, which is 25 degrees. Did I do that right? They're both 25? Yep, they're both 25, the side and the angle. So if I type the blue into my handy-dandy calculator, you'll notice the blue, when you type that into your calculator, the 32 sine of 25 is 13.52. We'll bring down to 25. Now, we know that 25 is larger than the blue. We see that right here. So that means we have two triangles. And as I mentioned before, if you have two triangles, all you have to do is state that you have two triangles. You don't actually have to solve it. If it was one triangle, yes, you'd have to solve it. And now we have one last problem. It's a word problem. So yes, we have to read through this. Then we're going to draw it to help us out. We know that we have a road that's 11 miles long between two ranger stations. Then we have a fire. Here's our fire. We know that the one angle from the ranger station to the fire is 48 degrees. We know the other angle from the other ranger station to the fire is 53 degrees. So this is our second ranger station, where the over here would be our first ranger station. Now we're trying to figure out how far apart it is from each ranger station. So basically, we're trying to figure out the blue, and we're trying to figure out the green. Now, we have the black side in between our two angles, so it's an angle or angle side angle. So it's only one triangle. We don't have to be concerned about number of triangles with that flow chart. We find our missing angle, because remember, all the angles in a triangle add up to 180 degrees. So when we do that, we get our missing angle to be 79 degrees. We now have the fire and its opposite side of 11 as our pair, so we can go ahead and use law of sines. So I'm going to go my x over the sine of my angle opposite that, which is 53 degrees, is equal to, and use my opposite pair, my 11 over the sine opposite of that, which is 79 degrees. Get rid of dividing by sine of 53, so multiply both sides by sine of 53 degrees. Type that into our handy-dandy calculator, and we get 8.95 miles. Now, if we're looking for the y, I'm going to go y over the side opposite, or I mean the angle opposite, equals my opposite pair, my side over the sine of the angle opposite. Then go ahead and get y by itself, so multiply both sides by the sine of 48, so I get 11 sine of 48 degrees over the sine of the angle opposite. Type that into my handy dandy calculator, and I get this.